Hi everyone. So in this lecture we're going to talk about adding and subtracting integers and real numbers, and so we're going to start with some properties here. First thing, absolute value of a real number. So the absolute value is just the distance away from 0 on the number line. Okay, and the notation for this is you put these little bars around the value. So this would be the absolute value of x. You would read that. Pretty much all you're really just doing is you're just dropping the sign. So like absolute value of 5 is 5, absolute value of -5 is 5. You're just really dropping the sign because that's giving you sort of like the distance on the real number line. If you wanted a visual for that, here's 0. And here's 5, so this distance right here is 5, which is the absolute value of 5. Okay, and then if you were at -5, well, the distance to 0 is still 5, that distance there. So the absolute value of -5 is 5. So if you kind of look at it this way, really all you're just doing is you're just dropping the sign. Okay, if you're already positive, you're not going to change. It's the same. But if you're negative, then you just drop the sign in front of that. So that's a simple way to think of it, but that's how it's geometrically tied into this definition here. And then opposites, the opposite of a number, these are just numbers that are the same distance from 0, but in opposite directions from 0. So in other words, you're just negating them, right? So they're numbers, the same distance, from 0, but in opposite directions from 0. Okay, so let's just start with some basic examples. What's the opposite of each of these numbers? So the opposite of 6, well, that would just be -6. Okay, the opposite of -9, well, that would just be 9. So you're just really negating them when you're talking about opposites. Absolute value, these are also pretty simple. If they're positive already, then you don't have to do anything. Absolute value of 4 is 4. But if they're negative, absolute value of -7, this would just be 7. So you're just dropping the sign. Okay, now here you have to be a little bit careful with the notation because here we're saying negative the absolute value of 3. So if you simplify just this part, the absolute value of 3 is 3, but this negative is still in front of it. So you see that it's actually, you see we're just replacing the absolute value of 3 with this 3, but this negative just gets carried along. Okay, that's different than if you took the absolute value of -3. That would actually be 3. Okay, just notice the difference in notation there. What about this one? So 9 minus 4, and then take the absolute value. Okay, so first let's just simplify what's in the absolute value here. So this would be the absolute value of 5, and then minus the absolute value of 8 minus 6. So this is the absolute value of 2. Absolute value of 5 is 5. Absolute value of 2 is 2. So what would this be? Just 3, right? Moving on to addition of real numbers, we can kind of think of this geometrically. Addition, like 3 plus 4, you find your start, right? Here's your start. And just adding 4, you're just going to go 4 more. 1, 2, 3, 4. So that's how you're adding 4 to get to your result of 7. Okay, just kind of showing you this geometrically how you're doing this. This is for real numbers, but also integers. So our examples here are integers, but basically the same thing, regardless. 3 plus -4, so you can do the same thing, okay, as your start. But since we're adding -4, you're going to go in the opposite direction. So 1, 2, 3, 4. Right, so here's your end value. I should probably have written that up here. And so your answer is -1 then. I'm just kind of showing you this geometrically. You probably could do this arithmetic, no problem, but just kind of keep that in mind. One thing to notice here is -4 is larger in magnitude, and notice that the result under this addition, it was a negative number, okay, because it kind of overtakes the smaller number and gets it to its sign. And then in this situation, if you want to do the same thing, well, our start will be at -3. And we're going to go in the negative direction 4 times. So 1, 2, 3, 4, and we end up at -7. Okay, and again, notice here we sort of added them, but the magnitude did increase here. Okay. When you encounter multiple sums like this, there are several ways that you can simplify them if you want. You could add up all the positive numbers first if you want, and then add all the negative numbers and subtract them. Or you could just do them one by one. It doesn't really make a difference. So one way that you could just do this is, one way you could just kind of simplify this. So 3 plus -4 would be -1, and then -5 plus 10 would be +5. Okay, and then you can add these results to give you 4. Okay, so that's one way to simplify it. Another way to simplify it is you can add positives. So that would be 3 plus 10, which is 13. And then you can add negatives. So -4 plus -5 would be -9. And then you could just add the results. Right? 13 plus -9 would be 4 still. Okay, so that's just 2 ways that you could approach that. You can kind of do the same thing even when you have more complex things, but you have to keep in mind the rules that we have said that we've been following. So first thing that we should do is remember PEMDAS, right? So we want to do what's in parentheses first. So we have -10 plus 2, and then what's in here, -8 plus 11. This will be +3. Okay, and then we have this multiplication to do next. So we'll have 6 here. And now you could just simplify them one at a time if you want, or you could do the same thing that we did before. It doesn't really matter. This would be -4, and then finally -8. So we can kind of summarize what we just kind of noticed up above. If the two numbers have the same signs, like if they're both positive or both negatives, then they are going to keep the sign. Right? But if they happen to be different signs or opposite signs, so different signs, then you'll have to subtract, and then you keep the sign of the larger number, meaning larger number in magnitude. So just to kind of backtrack and show you what happened there, let's say they had different signs, like in this example here, 3 plus -4, right? -4 is the bigger number in magnitude, so when we do add these, you keep the sign of the larger number in magnitude, so it's going to go more negative because of this, right? So it's going to stay consistent, stay negative. So kind of keeping in mind what we just saw up above, you could just generalize this notion of addition to subtraction. So for subtracting things, right, you could write it as a minus b, or you could just think of it as a plus -b. You're adding the opposite, right? So in other words, subtraction is just the same as adding the opposite. Okay, so you could evaluate the following, right? 8 minus 3, this is just 5. 2 minus 6, you can think of this as 2 plus -6. So remember, we're going to end up with the sign of the larger one in magnitude, so this will actually be -4. -11 minus 13, again, we can think of this as -11 plus -13. Okay, now they're the same sign, so we're going to end up with a negative, but then we just add these, so we'll get negative 24. Okay, negative 7 minus 3, this is the same thing as negative 7 plus negative 3. So again, we're going to keep the sign because they're both negative, and this will be negative 10. So whenever we subtract a negative number, two negative signs can be replaced with an addition sign. Right? Okay, so if you happen to encounter something like this, a minus negative b, we could just replace the double negative with a positive. Okay, that'll make your life a lot easier when it comes to simplifying these things. So let's do a bunch of examples here. So let's say we have 15 minus negative 19. Well, this would just be the same thing as 15 plus 19. So that's 34. Okay, negative 24 minus minus 2 is the same as plus 2. Okay, and what is this going to be? Well, the negative 24 is the bigger magnitude number, but we're still going to have a negative in the end, but this will be negative 22. Okay, and then negative 7 minus minus 10 will be plus 10. And then here the 10 is bigger in magnitude, so now we know that that's going to be a positive number in the end, and this will be positive 3. One other thing we have to keep in mind that's subtle is just sort of the way you're using the language of subtraction. So when you say to subtract one number from another means, you know, if you were to say subtract a from b, then we're saying that we're taking b and we're going to subtract a from it. So subtract a from b means actually b minus a. Okay, if you wanted a minus b, that would be subtracting b from a. All right, so just be aware of this. So evaluate the following. So subtract 5 from negative 1. So we're starting with negative 1, and then we're going to subtract 5 from it. So again, this is going to be negative 1 plus negative 5. So we're going to add these, but keep it negative, right? So negative 6. And then what about this more complex situation? So we have so notice here we do have a double negative. So first let's simplify this a little bit. So negative 3 plus 4 minus 9, and then plus 2 plus 5, right? Okay, so let's, I mean, I don't know, we could just kind of do this one at a time. So here this would be 1, this would be negative 7, and then we still have that 5 there, okay? This would be negative 6 plus 5 would give us negative 1. Again, you could have also done add up all the positives and then add up the negatives and, you know, add those. But you can kind of just do it systematically one at a time too. When we say things like find the difference between one number and another, you're really talking about the distance between those two. So the difference between 9 and 2, then we would say 9 minus 2, which is 7. So how far is 2 from 9 there, right? That difference. Another way to actually think about that is it's the absolute value of the difference. So if you took the absolute value and you ended up getting negative 7, well, the absolute value would make sure that it's positive, so you're actually getting a distance there.